Okay, welcome to the NUPOC video study guide number 41. Let's finish up question 2 in the differential calc section of Math 1. So we're going to do this last part here, which asks us to go over the quotient rule, which you'll recall is for when we have a function that has a numerator that's a function of x and a denominator that's a function of x. So when we take d dx of f of x, we're actually taking d dx of g of x over h of x, which ends up being this formula here, which we'll apply in an example, and then we'll see how we actually derive this formula, which is actually from the product rule, which is kind of cool. So if we have some f of x here, for example, which is x squared over 3x, right? And this is our g of x and this is our h of x, following this formula here, the quotient rule, right? We will just get, this will be 3x times 2x, right? That's the derivative of our g of x times our h of x, minus our g of x times the derivative of our h of x, which is 3, all over our h of x squared, which will be 9x squared. So this comes out to be 6x squared minus 3x squared over 9x squared. So no matter what x we would put in here, we would actually cancel out. We would have 6x times x here, 3x times x, 9x times x. So no matter what x we put in, we would cancel that through all of our terms. And we can also cancel a multiple of 3 in all these terms here. And of course you can graph those functions, graph this function, and then graph it with canceling out the x's, and you'll get the same result just to check it. And so what we end up with is 2 minus 1 over 3, which is 1/3. So this derivative is actually a constant, 1/3. So it's actually a constant slope to this function here, x squared over 3x, and that slope is 1/3, which sort of makes sense because you can see here this is a squared in the numerator, and then we've got a what do you call it here, a linear term in the denominator, so it's some parabola divided by something linear, and since we know that a parabola is just two linear functions multiplied together, we're sort of dividing out one of the linear functions, and we should be left with a linear function, and so just a line essentially, right? And that line has constant slope, and so that's the result that we get here, is constant slope. So that seems to check out. Alright, so that's how you would apply it in an example. Now let's go ahead and see how we would derive this quotient rule here. So we already know this. We know we have some function f of x equals g of x over h of x. And so I'm going to just ignore sort of the parentheses x, right? So f of x is just going to become f for this, just to make it faster. Right? So we know we have some f equals some g over h. Well, that means that g equals fh, right? So now if we go ahead and take the derivative of both sides, we'll have g prime equals, now let's use the product rule here since these are both a function of x, so we'll get f prime h plus f h prime, right? Now what we're looking for is f prime, right? So we're looking for, this is our function, and we're looking for d dx of this function. We're looking for f prime, right? And that's the same as taking the derivative of g over x, like we just did here. So rearranging this then, to get sort of this f prime term on one side of the equation, right? We'll end up with f prime h equals g prime minus f h prime. Dividing through by h, we'll get f prime equals g prime over h minus f times, let's just bring the h through first. Let's divide by h first. So this term is going to be 1 over h. It's dividing by h from the other side of the equation, times f, right, which is just g over h, times h prime. I'll just put h prime over 1 here. So this is going to equal, right, g prime over h minus g h prime over h squared. Now to get a common denominator here, we'll just multiply this term by h over h, or multiply it by 1. So I'll just write it in here, h over h, right? So what we have is f prime equals g prime h, or hg prime, whatever, minus gh prime over h squared, right? So now we have this common denominator. So we'll just rewrite it to have the exact same form we have up here. So we'll be able to say f prime equals h g prime minus g h prime over h squared, or as probably some of you learned it, certainly how I learned it, just as a memory device, is f prime is just, if we call h our low function and g our high function, it's low d high minus high d low over low squared. So that's it, just a quick example using the quotient rule on a pretty simple function, and then just going through the derivation via the product rule for how we get the quotient rule for taking the derivative of a function who has a numerator and a denominator that are both a function of x.